Alrighty, we're gonna continue with experiments. I'm so excited to see you guys tomorrow. It is so weird to go. It feels like forever. I mean, technically, well, I guess it's 3 days. I feel like it's 3 days. Saw you on Tuesday, I don't see you till Friday. It's just so weird to go that long in between seeing you guys. So, today, we're gonna keep talking about experiments. We're actually going to design an experiment. And then I get to see you guys tomorrow. So excited. All right. So, some more definitions. What? So many definitions. In an experiment, we must always use random assignment. So we talked about with samples, we always have to have randomness. Same with experiments. You have to have random assignment, or it's not an experiment and you can't prove cause and effect. And by the way, random assignment, I abbreviate as RA, especially when designing my experiments. It's much easier to write RA than random assignment. Like I've said before, I'm lazy. So, you have to use random assignment to assign the experimental units to treatments. So this means using some sort of chance process. So using table D if you want, or flipping a coin. Like if there are only 2 treatments, you could say heads is treatment 1 and tails is treatment 2 and just flip a coin for every individual. You could use dice, that's a chance. All right, sorry, I paused my recording because somebody came in. I think I had just finished talking about chance process, using the coin, the dice, the table of random digits. So, and if I had started into the next thing, I'm sorry for repeating. When the treatments are assigned to all the experimental units completely by chance, we have what is called a comparative randomized design. A control group provides a baseline for comparing the effects of all the treatments. And if you have multiple treatments, that can serve as a control group. So you don't necessarily have to have a control group if you have 2 or more treatments. I feel like I should have zoomed in, sorry. So now, like I said, we're going to design our own experiment. All right. So North has decided to offer an SAT prep class again this year. That's a lie. They're not. But we're going to assume they are. It will be offered in 2 different formats, online or classroom teacher. The counselors want to know which teaching method will yield higher SAT scores, so they have allowed me to set up an experiment. 50 students have signed up to take some form of the SAT prep class. So we're going to discuss an appropriate experimental design and outline it below. And this reminds me of tree diagrams. So we're going to start with our experimental units, or in this case, subjects, because they're human beings. So we have our 50 students. Here is the most important step in designing an experiment. Random assignment. Remember I said that I'll use RA. So random assignment, I'm gonna describe it down here. If it's short enough, you could write it right here, but if it's not a short description of the random assignment, I suggest writing it below the diagram. If you put RA and you don't describe how the random assignment is done, you're not going to get full credit. So I have 50 students, and I'm looking at online and classroom teacher. So my random assignment is going to break them up into 2 groups. I'm going to call this group 1. And I'm going to end up with 25 students in that group. And this is group 2. And I'm going to end up with 25 students in there as well. 25 and 25 is 50. In theory, I'm going to use a different color. Random assignment, just like randomization in our surveys, in theory, is going to create similar groups. So they should mirror one another, and they should mirror the population so that we can make inferences. That is the whole reason for random assignment and experiments, using some sort of randomness in our samples, is so that we can mirror the population and these groups mirror one another. And then I'm going to say group 1 gets treatment 1. And I'm just going to go in order, so online class. It doesn't matter if I call treatment 1 online or the classroom teacher. That's a really weird one. Sorry, I didn't notice it until I can't always write and speak and do anything. And this one will be with teacher. I'll just say teacher. I wanted to say in person because that's how things are this year. You're online or you're in person. And then the last step is also important. I have lots of kids who want to forget this step as well. And that is, after the treatments, you're going to compare the results. And in this case, what we're going to compare is their SAT scores. Because we want to see which one's better, the online prep or the teacher prep. Now, like I said, we actually have to describe what the random assignment means. So I think I'll use a different color. Random assignment has to use a chance process. So like I said, because there's 2 treatments, you could use a coin. And, well, let's start here. So first thing, like with all our stuff we've been doing so far, is we're going to label each student with a number. 1 to 50. Just sticking with table D because we've been using that a lot. So I guess I should say 0, 1 to 50. Use table D from the label and then until I got 25 unique numbers between 0, 1, and 50, and I would put them into group 1. And then the other 25 numbers that are left between 0, 1, and 50 go to group 2. Use table D. That's our table of random digits to get 25 unique numbers between 0, 1, and 50. So that's telling you to ignore numbers outside that range. Unique tells you you can't have repeats. Those go to group 1. Rest go to group 2. But like I was saying, you could use a coin and just flip for each kid. So you've labeled the kids 1 through 50. For the first kid, flip a coin. Heads is group 1, tails is group 2. You would only go until you got 25 in one group, because that may happen sooner than actually doing 50 flips of the coin. And then whoever was left would go into whatever group needs to be filled back up. So do we need a control group here? No, we don't, because we have 2 treatments. If I only had 1 treatment, then I would have to have a control group. But since I have 2 separate treatments I'm imposing, I don't need a control group. So here's a question that is similar to what you'll see in your homework and similar to what we just did. So I'm actually, usually the kids in class, so that's where I'm hemming and hawing. I'll read through it, and then I think I'll have you try 1 and 2 on your own, and then we'll do 3. So I'll have you pause, try those on your own, check your work with mine. So it says, music students often don't evaluate their own performances accurately. Can small group discussions help? The subjects were 29 students preparing for the end of semester performance. That is an important part of their grade. Assign 15 students to the treatment, and then that treatment is videotape a practice performance. Ask the student to evaluate it. Then have the student discuss the tape with a small group of other students. The remaining 14 students form a control group who watch and evaluate their tapes alone. At the end of the semester, the discussion group students evaluated their final performance more accurately. So first, outline a completely randomized design for this experiment. So I want you to pause and try 1, and I want you to try 2, which is describing how you carry out your random assignment. And provide enough detail that a classmate could implement your procedure, or like I said, enough information that when I grade your tests, pretending I don't know anything about math, that I would understand what you're saying. So go ahead and pause. Try it on your own. All right, so hopefully you tried it on your own. So we're going to start with our 29 students. Those students are then randomly assigned. Group 1 is going to have 15 students, because it tells me 15 students are assigned to the treatment. So they're going to get the treatment, which is watching the videotape and then small group discussion. So small group discussion. And then 29 minus 15 means that 14 students would go to group 2. And those students are our control, so they do it alone. No small group. And then, like I said, this one's often the forgotten one. We compared their final performance accuracy. Compare performance. That's a long word. performance, evaluation, accuracy. That's a lot of long words. Oops, sorry, I went off the screen. There we go. And then 2, you were to try on your own. That's describing random assignment. Now, you might have done a different random assignment than me, which is absolutely fine. I'm going to stick with table D. We're going to label each student 01 to 29. Use table D to 14, and I chose 14. You could have said 15. I chose 14 because it's less work. To get 14 unique numbers between 01 and 29. Those go to group 2. The rest go to group 1. Like I said, you might have done it a different way. Oh, excuse me. So what is the purpose of the control group in this experiment? So flip back here. A control group provides a baseline for comparing the effects of all the treatments. So the control group is going to give us baseline data to compare if the students who were in the small group discussions, if they evaluated their performance more accurately. So I don't know if this is how it works in music. So if I'm wrong, just bear with me. But it makes me think like your final end of semester performance is out of 100 points, and they give you a rubric that tells you how you get those 100 points. So the control group watches their video by themselves, gives them their grade, and then the teacher grades them, and we compare the kids in the control group who did it by themselves, no small group discussion, see how closely they got, how their score compared to the score they actually got. And so that would give us baseline data to see how well kids can evaluate themselves. And then we would do the same thing. They would give themselves a score out of 100. Teacher gives them a score out of 100. And we would see if the control group was better at getting a similar score as the teacher, or if the kids who got the treatment were. So it allows us to say, yeah, this actually worked because they did a lot better than the kids who didn't have that treatment. So a control group's whole purpose, that pen does not want to work, is to give us baseline data. There are 4 principles of experimental design, and you can bet I'm going to have a question about that on your test for this unit. I do it every year. Every year I tell them it's going to show up, and every year I have kids who forget to study it. All right, so number 1, compare. Use a design that compares true 2 or more treatments. Random assignment, RA. Use chance to assign experimental units to treatments. Doing so, Doing so helps create roughly equivalent groups of experimental units by balancing the effects of other variables among the treatment groups. Control. Keep other variables that might affect the response the same for all groups. And then replication. Use enough experimental units in each group so that any difference in the effects of the treatments can be distinguished from chance differences between the groups. So, excuse me. Replication, to me, it makes me think of like repeat it. But really what it's talking about is sample size. So, get my highlighter. It's right here in the beginning. Use enough experimental units. If your sample size is too small, you can't say that the treatment is the reason for the difference. It could just happen purely by chance with a really small group. But if you have a big enough sample size, remember I talked about how a bigger sample size alleviates a lot of issues in statistics. If your sample size is big enough, then any difference between the treatments cannot be attributed to just happening purely by chance. So replication, like I said, makes me think like repeat, and like do the experiment over again. That's not what it means. It means use a big sample size. All right, and then of course, just with samples, experiments can have issues. So, experiments, what can go wrong? Some experiments give a placebo, which is a fake treatment, to a control group. That help prevent compounding due to the placebo effect. Sorry, forgot I had a video I want to show. I can't do it under my doc cam. So placebos help prevent compounding due to the placebo effect, in which some patients get better because they expect the treatment to work, even though they have received an inactive treatment. In an experiment, you do not want the experimental units to know which treatment or placebo they have been given. So when the experimental units don't know, that means the experiment is single blind. In addition, you really don't want the experimenters, the people administering the treatments, to know what treatment the person is getting, either the actual treatment or the placebo. And if you can accomplish that, this experiment is known as double blind. Double blind is better than single blind, but there are some experiments where double blind is not possible. So I did have a video about the placebo effect. So I'll put the link in Canvas. It is in Canvas with this video for you, so you can watch it. I find it interesting, but I am weird. So, is it gonna cause you to not be able to pass your test if you don't watch it? No, but it is interesting. And then in an interesting experiment, researchers examined the effect of ultrasound on birth weight. Pregnant women participating in the study were randomly assigned to one of two groups. The first group of women received an ultrasound. The second group did not. When the subjects' babies were born, their birth weights were recorded. The women who received the ultrasounds had heavier babies. Did the experimental design take the placebo effect into account? So do we have a placebo, a fake treatment? No. Doesn't say anything about giving women a fake ultrasound. So no placebo. And that's important because, I don't know, I guess as somebody who's had kids, that the first time you see your baby on an ultrasound, it becomes a lot more real. Actually, the first time you get kicked by your baby, it becomes a lot more real, at least in my opinion. So seeing the actual baby might be, the mom might be like, oh my gosh, it's a baby, I need to eat really healthy and take care of myself and get lots of sleep and not drink caffeine and don't eat fish or don't eat that, don't eat this. So many restrictions on what you can eat. Anyways, so let's say seeing baby influences mom to take better care of self. Was the experiment double blind? So double blind means that the subjects, in this case the pregnant women, wouldn't know they got an ultrasound, and the people who recorded the birth weights wouldn't know about the ultrasound. So the people who recorded the birth weights, probably that could be blind, although they have access to all your medical records when they're helping you in labor and delivery. So that part could be blind. They could bring in somebody who hasn't had access to your medical records and say, hey, you get to weigh the baby. But the mom, for sure, is going to know she had an ultrasound. So no, it's not double blind. Mom knows she had ultrasound. And then the last one. Based on your answers, the questions 1 and 2 described an improved design. Okay, well, an improved design would take the placebo effect into account, and we would try to make it double blind. So I suppose you could give a fake ultrasound. I mean, the only reason that I know that the ultrasound tech is actually giving me an ultrasound is because I get to watch it. So I suppose you could not. Nowadays they have TVs in the ultrasound room, so you get to look up at the TV. So they could not turn the TV on and turn the ultrasound machine away from you so that you don't know whether you're getting an ultrasound or not. So the ones who get an ultrasound, they turn the machine on. The ones who don't actually get an ultrasound, they go through all the actions, but they don't actually do the ultrasound. So that would be the placebo, giving a fake ultrasound. And then double blind. So if the TV is off and the ultrasound machine is turned away from the mom, then she wouldn't know whether she's getting one or not, because the tech goes through all the motions. But she wouldn't see anything, so she wouldn't know if she had one or not. And then, like I said, they could make sure that whoever weighs the baby didn't have access to the medical records, or in this case, the experiment records on whether the mom had the ultrasound or not. So you could make it double blind. And I'm going to paraphrase as best I can. So, placebo effect, give a fake ultrasound. And then double blind. Nurse way without access to records. And that is it for today. Yes! So I get to see you guys tomorrow. Yay!